multiply two radicals together, you can put what's underneath them together in a multiplication. Or you can also do the opposite, separate a multiplication. You cannot do that with a plus and a minus sign. You cannot do that. Okay. The other rule is if you have division, then you can separate the fraction into two different radicals, and vice versa. You can put them together. Okay. All right. Now, there's something called rationalizing the denominator. That means you cannot have a radical in your denominator. So we must rationalize them. I'm going to show you how to do this. You're not allowed to have decimals in fractions. You're not allowed to have radicals in your denominator. You're not allowed to have fractions inside of fractions. Okay? You can have a radical in the numerator, but you cannot have it in the denominator. Yes?
So then how can you have the square root of A over the square root of B?
That's just showing you that you can separate them, and then you have to do something with the b. If you can't take the square root of it. Okay. All right. So here's an example of rationalizing the denominator. If we use something like this, we'll just use a over the square root of b. Okay. How you rationalize it in simple terms is like this. Remember, you can multiply anything you want in an equation, provided you do to all terms. Well, here we have an expression. The only thing you can do to change this expression, change the way it looks, is if you multiply by 1. That doesn't really change the value, does it? So 1, in this case, would be the square root of b over the square root of b. Isn't that 1?
Yeah.
Okay, this is why we can do this. Now, the square root of b times the square root of b,
Square root of b squared.
which is the square root of b squared. What's the square root of b squared?
B.
b. Without the radicals, the denominator is now b. The top is a radical b. That is called rationalizing your denominator. Don't worry. Factoring will come into play eventually.
Today.
No, not today. All right, so example 1. Lots of examples. All right? So 2 over the square root of 3. Everybody rationalize that, and just like what we did with the a over the square root of b. And we'll go on. Most of these are short responses, provided you do what I tell you to do. How we doing?
Great.
Who got it right? Excellent. Good. It'd be neat if that was it. But it's not. Example 2. How about 2 radical 7 plus the square root of 63? Do not do this. Just write it down. Radicals are like variables. That's how you should treat them. If you can simplify them, great. If not, then treat them like it's a variable. If you have like variables, then you have like terms. Okay? So, and I also want to talk about simplifying radicals at this point. 63, using this first rule here, we can make that into the square root of 3. Let's actually do the square root of 9 and the square root of 7. Isn't that the same thing as the square root of 63?
Yes.
Anybody not understand that? No. Now, do you know what the square root of 9 is?
3.
Okay, so the square root of 63 simplifies to 3 radical 7. So now my expression says 2 radical 7 plus 3 radical 7 you have like terms. How many radical 7s do you have now? 5. So this simplifies to 5 radical 7. This is if that was 2x plus 3x, you would have 5x. Everybody catching on? Pretty simple. Great. Because we need you to really get this before we do factoring and putting multiple things together with plus and minus signs. Okay? Yeah.
There's no graphing tonight, right?
No.
Does that know that in the of our answers?
Yeah, this would be your answer now. You're not going to put this in your calculator. All right? So if we go back to the quadratic formula, you can leave what your discriminant is under the radical as part of your answer, unless it's specifically wanting you to find exactly where the zeros are on the graph. Anyway, that's a little extra. So example 3 is the square root of 20. Everybody simplify that as far as you can. This is just like reducing. You're not using a calculator, you're just simplifying. Manipulating numbers. I told you this is manipulation, not algebra. Sarah, what two numbers multiply together give me 20?
2 and
Yeah, we can do 2 and 10. What other two numbers?
10. 4 and 5.
Are there two others?
No.
You can use 1 and 20, but that kind of defeats the purpose, doesn't it? Okay. So I'm showing that it doesn't matter how you do it, you're going to get the same answer. I don't know what the square root of 2 is, and actually I'm going to go do this one first. What's the square root of 4?
2.
Now, can I simplify the 5 any further?
No.
No. Okay, so that's really the answer, but let's look at this over here. How are we going to get the same answer? The square root of 2 does not simplify any further, but 10 does. What does 10 go into? The square root of 2 and the square root of 5. So now you have 3 things. So really, this could be whatever a times b is. Okay, it could end up being a times b times c, or a times b times c times d. Okay, you don't have to just get it down to 2 different things. It could be multiple things like this. The square root of 2 times the square root of 2 times the square root of 5 is 2 times 2 times 5, the square root of 20.
Is Tracy in here?
No. Yeah, he'll be over there. Okay. So now here's the trick. What's 2 times 2?
4.
So the square root of 4 is? 2. Okay. So in a square root, whenever you have the same numbers, it's just that number without the radical. Right? Okay. So this becomes 2 radical 5. Okay. Now if you have to write the square root of 4 times the square root of 5 and then 2 radical 5, that's fine. Okay, whatever it takes for you to really get it. Anybody lost? Okay. Example 4. Long way to go. Now, what about variables?
X to the 1/3 power.
Yeah.
Is it still a square root radical?
Okay. What does the square root mean? If I say the square root of 4, why is it 2? Yeah.
Because 2 times 2 equals 4.
Because 2 times 2 equals 4. Okay? Why is the square root of x squared x?
That's x times, so.
Well, how do you get 2 for your exponent then?
So there's only 2.
Oh, no. That's the simple way of explaining it. How do we get the 2? When we multiply like bases. Yes?
Don't you add the exponents together?
Yes, you add exponents. Okay? So it's a little different. When we take the square root of 4, you're multiplying 2 times 2. Yes, the square root of x squared is x times x. But the 2 comes from adding the exponents. So if I do this, I'm just going to show you. Are those two the same thing?
Yes.
Okay, now don't I have the square root of x squared up there?
Oh.
So that's x times the square root of x. I just switched them. Everybody understand?
Yeah.
Okay, so square root of 60, let's do the square root of 61. Sorry, stop. So not what I wanted. Square root of x to the 61st power. What would you do? I would just take one x to the side to make this even, because you take the square root of a variable, you're adding the exponents. Two bases multiplied together, you add the exponents, what's that going to be?
Can we just take out two x's and then it could be x to the 59? X times square root of x?
No. What two x's multiplied together, what do the exponents have to be to give me 60? What are the exponents here if I multiply these two together to give me 60?
30.
Two and three.
You know, you add exponents when you multiply like bases.
30.
30 and 30, right? Isn't x to the 30th times x to the 30th x to the 60th? Yes? Okay, so the square root of x to the 60th is x to the 30th. And I still have a radical x to the first in left over. Okay, what's the square root of a to the 29th? Everybody take a second. Showing you the shortcut. So what's the square root of a to the 28th, Brody? What two variables, a to something times a to something, will give you 28? They have to be the exact same. Remember, square root means you gotta have the exact same. So what do your exponents have to be on these two a's to get 28? These exponents have to be the same. How do I get 28 out of these two exponents? You multiply like bases, you add the exponents, right? So what same number adds up to 28? Yes. So the square root of an even exponent is half of the exponent. You get it? That half of 2 was 1. Half of 60 was 30. Half of 28 is 14. You still have an a to the first left over. So if you have the square root of an even exponent, you're not going to have any variables left over inside. So this is just z to the 7th, because z to the 7th times z to the 7th is z to the 14th. The square root of 16 is 4, because 4 times 4 is 16. The square root of z to the 14th is z to the 7th, because z to the 7th times z to the 7th is 14. So your variables, you take half of the even number. Yes?
So why is it just z to the 7th and not z to the 7th times z to the 7th?
So the square root of 16, why is that not just 4 times 4? Because 4 times 4 is 16, not the square root of 16.
There's a square root.
Okay?
Oh.
So you don't write, it's understood that that's what the square is. That's what your root of that square root is. Okay? Alright, example 5. So that's variables, don't screw that up. So if you have an odd number, take 1 and leave it under the radical. Okay? Alright, what do you say? Square root of x to the 11th. Do it. Example 6. Square root of x to the 27th. Example 7. Square root of x to the 7th, y to the 4th. Do those three. And I'll write the answers down here in a second to see how you did.
Mr. Walker?
Yeah.
Okay, so I'm wondering something. On example 5,
Yep.
could you take x and then do divided by the square root of x and make it x to the 12th?
Okay. Remember, in an expression, you either are going to multiply by 1 or you can divide by 1, because that doesn't change the expression. If you divide by x, that's really not 1. You're not dividing by 1. If you want to multiply by x over x, that's 1. You see what I'm saying?
But I'm saying
You cannot divide by x.
but you multiply to get rid of 1, so can you divide to add 1 and make it
Only if you're multiplying by 1 or dividing by 1.
Okay.
Because that, if you do anything other than that, you change the value of the problem.
Okay.
We're just manipulating the same value. Okay? So here again, you just want to take the x to the first out, and you have x to the 10th, which is, yes? Yes. That's the answer. We got it right. Okay. This one, again, I just take an x to the first, that's x to the 26th, that's x to the 13th times the square root of x. We got that one right. Okay, I'll give you a second to finish this one. Make sure you understand when you have a radical and when you don't have a radical. Don't just be putting a radical around something just to do it. Square root of 16 is not the square root of 4. Right? Square root of 16 is just 4 without the radical sign. Make sure you don't just put radicals in wherever. Alright, so this is just two problems. Square root of x to the 7th and the square root of y to the 4th. That one's easy. That's going to be y squared out in front. This one becomes the square root of x to the 6th times the square root of x. That's x cubed. That goes out in front. And I have the square root of x left over. Who got that right?
I didn't put them in the right order. Yeah.
Okay, a times b is the same as b times a. X cubed times y squared is the same as y squared times x cubed.
Do you have it now?
Yes, you should put it alphabetically. The radical always comes last.
I'm stretching.
Okay. Who got this right again? Is there anybody totally lost at this point? We're not done by any means. Anybody totally lost? Huh? Quite a few. That was example 7. Example 8. Well, do you want to see them? Different possibilities, or?
Yes.
So make sure you have your notes out while you're doing your homework. The square root of, we haven't done these yet, 144 over x to the 6th.
Same thing as.
So what do you have? You really have two problems in one. You're going to separate them, right? Now sometimes it will be beneficial to put radicals together. You need to make sure you remember to do that. Sometimes it'll make your problem easier.
12 over x.
Yeah. So if you just understood that, the square root of 144 is 12. The square root of x to the 6th, that's an even number. So that's x cubed. All right, who saw that? Who got it? All right, a little better. All right. Another one. Example 9. The square root of 2 times the square root of 8. There's two different ways to do this. One's fast, one's slow. if you look at it and you say, okay, they're breaking it down, let's break it down further, and you'll say, okay, the square root of 2 stays there, this becomes the square root of 2 times the square root of 4. Those two together just make 2, and the square root of 4 is 2, so the answer is 4. Or, you could have put them together and said that's the square root of 16, which is 4. You get the same answer either way. That should make you feel better. Okay? So you might have to work a little harder, but you have to pick and choose and try to think a couple steps ahead if you want to get it done faster. Otherwise, you're just going to do a lot more work. Example 10. 6 over the square root of 3. Careful. 6 over the square root of 3. Rationalize the denominator if you've forgotten. Don't forget how to rationalize the denominator because it's going to get more difficult later in the chapter. Stop biting yourself.
I'm not. Ow.
Stop. Stop. Okay. Rationalize the denominator. That's what you do. So that is 6 radical 3. That is just 3, but the 6 over 3 reduces. 2 radical 3. Who actually got it right? 2, 3.
How did you get that?
Wow.
6 divided by 3 is 2.
Oh, yeah, you're right.
Oh, yeah.
Oh, I thought you were
So anything, you can divide anything outside of the radical by the denominator if it goes in evenly.
Yeah, it's the same as anything else. Remember I said you could treat the radical like a variable. If that was 6x over 3, nobody in here would miss it.
Hey, would it be the same thing if the square root of 3 was on the denominator?
Again, you can't have the square root in the denominator, so you have to get it out of the denominator. You wouldn't be done
By doing what?
rationalizing it. Okay, now if you have a radical in the denominator that's the same as the radical in the numerator, you just cross them out. Right? Isn't that just 1?
Yeah.
Okay. Example 11. 3 square root of x plus the square root of 4x. Careful. Begin. I'm just saying, the reason these are up here because I have vast experience with student mistakes.
I bet I did it wrong because I was obvious.
That's why only 3 of you got the last problem right. Because I chose a problem that students normally make mistakes on. Is that right? No. You can't do that. The two radicals are different. Okay, it's just like x squared and x cubed. You can't put those two together.
Unless you're adding.
No, you still can't put x squared plus x cubed together.
Wait, multiply. Thank you.
Yes, if you're multiplying, that's different. But we're not multiplying here. And the square root of 4, just 2. We're not done. We're not done. These are now like terms. That's 5 square root of x. We got it right. 1, 2, 3.
I almost got it right.
6. I picked some good examples. Example 12.
Gosh.
Well, if I would have turned you loose after the 4th example, you'd all have your hands up in the first 30 seconds of doing your homework.
Yeah, you're right.
So keep your notes out to help you. Example 12. What? I hope so too. 6 radical 32 plus the square root of 12. Now you have to do a little work.
What?
Break them down. Break them down. Come on, you gotta go. Stuff to do. Oh my goodness. Break it down.
We can put it on the bed.
Oh, we got plenty of time. Treat each one like a separate problem.
I don't know.
It's rough. Sometimes things just don't work out the way you think they might.
I still don't.
Only do what you know how to do. You've been taught a lot, it's possible you've forgotten something. That's why you have notes, that's why you have a book. 9 times 30.
This is on 6.
How about 4 times 3?
I don't think
Yeah, that's what I did.
Now you could have chosen 4 and 8, but then you would have had to broken those down a little bit further. You could have chosen, oh, that's it. Okay, so, but I chose 16 too because I knew I wouldn't have to break it down any further. So that's 6 times 4 times radical 2 over 24 radical 2 plus 2 radical 3. Are those like terms?
No.
That is your answer.
Oh, gosh.
I just simplified it, that's all. Example 13.
What?
You're not getting these early, dude.
The square root of 5 plus 4 quantity squared. Yeah. Special case formula.
Give me time. I don't even know what the example is. Well,
Special case formula. Yeah.
Can you take the square root of a square root like that? You take the square root of the whole thing?
Of this?
Yeah, like the whole.
Oh, yeah.
formula.
Only if you have an equal sign though.
Oh.
Remember what I said?
Because you have to do it to the other side.
Expressions you can only manipulate by multiplying and dividing by 1. Whatever 1 looks like x over x is 1. But if you're going to do something like the square root, that means you must do it to the other side of the equal sign.
Yeah, that's what I was
There's no equal sign. Alright, so let's just do this the long way with FOIL, just to show you what goes on. You can use the special case formula if you wanted to. So the square root of 5 times the square root of 5.
5.
Square root of 25, which is 5. Square root of 5 times 4.
Square root of.
4 squared is 5.
Same thing. Times 2.
Got it. Okay, now do the next one. Oh, that's 4 square root of 5. That's where the 2ab comes in for your middle term. There's 2 of them. And 4 times 4 is 16.
Yeah, bro.
By my terms, 5 to 16 is 21. That's 8 square root of 5. That's your answer. Huh? What?
is that all these do?
Don't do something that you don't know how to do. Don't make up stuff. You guys like to make things up. Oh, I'm going to take the square root of this. Just because I can. Well, no, you can't do that.
I didn't end up doing that very
Example 14.
I have no room.
What? More examples?
3 over the square root of x cubed plus 4 over the square root of x.
I know what it's
I don't even know what to do.
Two separate problems. You do 2 separate problems in one. What?
Rationalize.
Well, square root of 5 times square root of 5 is the square root of
Get the
5 times
rational.
5. Square root of 5 times 5.
Hey, Hunter,
Square root of 20.
you have to rationalize these.
Yeah, I got that far.
That's the answer.
That's the answer.
You have 2 What's the number's the same, it's just that number without the round. Alright, you done?
Possibly.
Who's done? Alright, I'll wait a couple seconds. And we gotta go. It's one of my favorite assignments.
I'm telling the rest of us.
Because no,
What did she say?
once you get it, then it's like addition and subtraction to you guys. I mean, it'll click.
That's what you said about.
You guys agree? I said once you get it, then you'll like it.
Like it?
Well, for me. Anyway, so this one right here is 3 over x times the square root of x, right?
What? Not at all.
Because that's x squared times x. It's not done. It's not done.
Oh,
I'm just doing one step here.
okay.
X squared times x, so the square root of x squared gives me the x, and I have an x left over inside. Everybody agree? Alright, so I rationalize this by taking the square root of x times the square root of x over the square root of x. This now becomes 3 radical x. Here you have 2 radicals together that are the same. That's the square root of x squared, or
1.
x. X. And you have another x. So x times x is?
X squared.
Alright, so who simplified the left?
Hey, next period, can you give me a copy?
Yes. I'll bring it down.
What?
I'll bring it down.
Oh, okay.
Who's this?
Right now.
Okay.
No,
So, everybody see where the x squared came from?
Yeah.
The square root of x times the square root of x is the square root of x squared, which is just x. And you still have another x here, so x times x gives me x squared.
So if you want to do the root of x.
This one? Okay. So I skipped a step here. So that's the square root of x squared times x, right? So I really have the square root of x squared times the square root of x, because I can split them apart. The square root of x squared is x.
Oh, okay.
Okay? Alright, so that's the left side. Over here.
Oh, that's only the left side.
Over here you got rationalize this denominator. So that gives us 4 radical x over
X squared?
Oh.
I got that
I got that.
This is the square root of x squared when you multiply them together. But
I
what's
thought
the
it was
square root
like
of
the
x
other
squared?
one.
X.
X. Alright, so we have a plus sign. 4 radical x over x.
Can't do anything now.
Oh my gosh.
Well, we have fractions. Can't you combine fractions? How can you combine fractions?
Oh, like.
You gotta make the denominator the same.
Denominator.
He's in.
If I multiply this by x over x, that's 1.
Ow!
I then have a common denominator. So this is 3 radical x plus
Oh my gosh.
4x square root of x. This x goes right here. All over x squared.
Killing me.
Oh.
Did anybody get that right?
No.
Alright, now look.
Oh my.
Listen to me. If putting them together, like we did here, doesn't change anything. Like, I put them together to see if I could get these two to combine. Okay? And I can't combine them. So if they don't combine, then this is okay to leave it like this. Technically, you should leave it like this unless doing this changes the top. Okay? Where you can put them together. But you have to check. Yeah.
Why can't you have 7 times the square root of x over x squared plus x?
Sort of.
You just asked it, what? 7?
Why can't you have 7
No, 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 no,
No.
no.
Or
Besides
where
4
is
to
it?
54.
This-
See on the left side.
Is different than this.
I meant on the.
They're different bases.
I was
Yeah, the
talking,
square root of x is the same. In order to add these together, this has to have an x right here.
I was talking about the one above it. Where yeah, why can't that be 7 squared x over the x squared plus x?
Oh, no, no. Okay, so are you telling me
I don't know.
that 3 over 1 plus x over 5 is the same thing as 3x over 1 plus 5?
I don't know.
What is going on?
That's exactly the right answer.
No, this is not
What's
equal
up
to
with
half
that?
x.
I don't know.
Why not?
Okay. Alright, your assignment.
Oh my god.
Keep your notes close to you. 4 to 54 even.
What?
Our son